You look up at the sky, sometimes got airplane, sometimes got bird, but sometimes got something else. Something fast, something with a purpose, a very specific one, We talking about missiles, you see. These things, they are not your friendly neighborhood paper airplanes, whore. They are marvels of engineering, true masterpieces of human ingenuity, but also they carry a serious punch. They are designed to travel far, travel fast, and deliver something, usually something explosive, to a very precise spot. Think of them as very, very smart, very, very fast delivery drones, but the package is a bit more impactful, can say, missiles. The word itself sounds a bit scary, right? And for good reason sometimes. But today we're not here to scare you, okay? We are here to explore, to understand. How do these things work? What makes them tick, or rather, what makes them zoom across the sky, or even into space, and then come down exactly where they are told? It's a story of science, of physics, of incredible engineering. It's about harnessing immense power and guiding it with pinpoint accuracy. It's like trying to throw a needle across a football field and get it to land right in the middle of a tiny little dot, almost see the precision needed. So come, let's take a journey into the heart of the missile. Okay, so we know a missile is a smart, fast, pointy thing. But what's actually inside this pointy thing, Like any good machine, it's got different parts, each with a very important job to do. First up, usually at the very front, you have the warhead. This is the business end, the part that carries the boom or whatever payload it's designed to deliver. Then you need something to make it go, right? That's the propulsion system. This is the engine of the missile. And how does it know where to go? This speedy Gonzales? That's the job of the guidance system. This is the brain, the electronic smarts of the missile. Now, not all missiles are created equal, just like cars, got sports cars, got lorries, got family sedans. Missiles also got different types, each designed for a specific job, a specific kind of target, and a specific way to get there. First, we have the big boys ballistic missiles. Wow, these ones are serious business. They are like rockets that go into space or very high up into the atmosphere and then come screaming down onto their target. They can travel thousands of kilometers across continents even. Then you have cruise missiles. These fellas are different. They fly low, hugging the terrain, like a very fast, very smart drone. They have wings, and they use jet engines, more like an aeroplane. Next up, surface-to-air missiles, or SAMs for short. As the name suggests, these are launched from the ground, surface, to hit targets in the air, like enemy aircraft or other missiles. Finally, let's talk about anti-tank missiles. These are usually smaller, often carried by soldiers or mounted on vehicles. Their job is specific to take out armored vehicles like tanks. Small but mighty, these ones. Section 4, the power. How these fellas fly so fast one. So, these missiles, they don't just float around, They zoom. They need some serious power to get moving, to fight against gravity and air friction, and to reach their targets, sometimes hundreds or even thousands of kilometers away. This power comes from their propulsion system, their engine. One very common type of engine is the solid fuel rocket. Imagine a firework, a really, really big and powerful one. That's kind of like a solid fuel rocket. The fuel and the oxidizer, the stuff that helps the fuel burn, are mixed together and packed into a solid block. Once you light it, it burns like crazy, producing a huge amount of hot gas that shoots out the back, pushing the missile forward. Newton's third law in action, whore. For every action, there is an equal and opposite reaction. Simple, reliable, and can give a massive burst of speed very quickly. Good for when you need to get going, fast. Section 5, got GPS. How they know where to go? Okay, so the missile is flying super fast, got power, got zoom. But how does it know where its house is? Or rather, where the target's house is? It's not like it can ask for directions, excuse me, which way to the enemy bunker, No, Missiles use very clever guidance systems. These are the brains, the navigators, that steer the missile to its destination with incredible accuracy. One common system you might have heard of is GPS guidance. Yes, similar to the GPS in your phone or car that tells you how to get to your favorite make and place. GPS, or Global Positioning System, uses signals from satellites orbiting the Earth. The missile has a receiver that listens to these signals and can figure out its exact location anywhere on the planet. Then the onboard computer compares this with the target's pre-programmed coordinates and makes adjustments to the missile's flight path using its control surfaces, like little wings or fins to stay on course. Very useful for long-range attacks on fixed targets. But what if GPS is jammed, or not available? Or what if the target is moving? Then, other systems come into play. Infrared guidance or heat-seeking is one. Section 6. Faster than fast, hypersonic, and how to catch them. Just when you thought missiles couldn't get any more xiao, along come hypersonic missiles. Wow, these things are on another level of fast, really. We talking speeds of Mach 5 or more. That means 5 times the speed of sound or even faster. Imagine an object traveling so fast it could go from one end of Singapore to the other in just a few seconds. Blink, and you miss it, literally. This incredible speed makes them very, very difficult to deal with. It's like trying to catch a bullet with chopsticks, but the bullet is also maneuvering. Why so fast, you ask? Well, speed gives a huge advantage. Firstly, it reduces the flight time to the target. Less time for the enemy to react, less time to try and shoot it down. Secondly, the sheer kinetic energy of something moving that fast is immense. Even without a huge warhead, the impact alone can cause massive damage. And thirdly, some hypersonic missiles can maneuver at these high speeds, making them unpredictable. They don't just fly in a straight line or a simple arc, they can jink and weave, making them a nightmare for current missile defense systems. So how do you even try to stop something like that? It's a huge challenge, La. Existing missile defenses, which are designed for slower, more predictable ballistic or cruise missiles, find it very hard to cope. The sensors need to detect them much earlier. The interceptor missiles need to be much faster and more agile. It's a classic cat and mouse game, but the mouse is now on super steroids. Section 7. Change already the fighting impact on modern warfare. So after all this talk about pointy sticks that go boom, what's the big picture, whore? How has all this missile technology actually changed the way humans, well, the way they argue with each other on a big scale? The impact is massive, can tell you. It's not just about bigger explosions, it's about reach, it's about precision, and it's about changing the very nature of power and deterrence on the global stage. From the smallest battlefield to the grand strategies of nations, missiles have left a permanent mark, a deep crater in military thinking. Before missiles became so smart and so long-range, warfare often meant sending lots of soldiers, lots of ships, lots of airplanes, deep into enemy territory. Risky, costly, and many lives lost, but now, with missiles, a country can project power, can strike targets from hundreds, even thousands of kilometers away. No need to put your own pilots or soldiers directly in harm's way, at least not for that initial strike. This standoff capability is a game changer. It means conflicts can start faster, with less warning, and from much greater distances. The battlefield suddenly got a lot bigger and a lot emptier in some ways. Precision is another huge thing. Olden days, bombing was a bit hit or miss. You drop many bombs, hope some hit the factory, but maybe you hit the school next door also, Alamak. But modern guided missiles can be incredibly accurate. We talking about hitting a specific building or even a specific room in a building from far away. This reduces collateral damage, which is good, of course, but it also makes targets that were once safe now vulnerable.